In today's tutorial, we'll be building a metallic rainbow orb. We're going to be focusing more on just building the scene rather than getting into a ton of detail about how everything works. If you're interested in that stuff, I recommend watching the RayTK intro series. We'll also be applying some of the lessons from the recent optimization series to improve performance as we go. I'm going to be using RayTK version 0.38, but most of this should also work in the previous few releases in case you're using an older version of Touch Designer. Check the video description for a download link for the toolkit. We'll be building our orb using instance rings that are blended together. We'll apply color to the rings using a rainbow spectrum, and then the SDF blending will create gradients between those colors. Then we're going to add some twisting and rotation as well as a modular material. And then we'll do some post-processing to clean up the edges and use the bloom effect that was recently added to Touch Designer. As we go through this, I highly recommend saving regularly. There can be some stability issues with RayTK while setting up networks, so it's good to save often. We're going to be optimizing things as we build them, which should also help with the stability as well as just the shader compile times. The first step is to load the toolkit talks into your project. I like to do that at the root outside of the main project comp, but you can put it wherever you like. But I find that having it outside of that comp gets rid of a lot of the kind of noisy data connections that show up in the network. Open the RayTK palette with Alt-R, and then you're going to type in RayMarch Render 3D. And click that to create a renderer. And then going to create a null top connected to the output so we can see the rendered image. With the renderer selected, use the shortcut Alt-Shift-R to open RayTK's Editor Tools menu. And then within that, under Add Camera, choose Look at Camera. On the camera, we can keep the FOV angle at 60, and for the position, let's move it a little bit up into the side, so maybe like 1, 1, and 5, and that will give us a little bit better view as we're working. In the final scene, it's not really going to matter since we're going to have a roughly spherical shape, but it'll help us to see what's going on while we're building stuff. Next, we'll create the SDF that will be the basis of our scene. The goal here is to create a ring shape, and there are a bunch of different options for doing that, like a torus SDF or revolving a 2D SDF. But in this case, I'm going to be using a squashed prism SDF because it gives us some more variation in the shape than you'd get from a torus. So open the palette again with Alt-R, and then we're going to type in prism SDF and create one of those, and then connect it up to the first input on the renderer. This operator gives us a polygonal kind of cylinder-ish shape, and by default this doesn't really look like a ring, but it has this hollow option which we can switch on there, and that kind of carves out the middle and gives us just the outside bit. So now if we drop the height down to around 0.1 and bump up the radius to around 1, and then pick a different prism type. I'm going to go with octagon, but you can pick one of the other ones if you want, or even a custom one with a custom number of sides. But I like octagon because it has some corners in it that add some variety to the shape, but not so few that it stops being kind of round. The prism SDF also has this rounding parameter that lets us kind of blend between that and a round cylinder, or in this case, ring. Interesting thing to note about that is you can actually push it outside of that 0 to 1 range, and it produces some kind of interesting results. If it's below 0, it doesn't tend to work well, but things kind of glitch out there, but larger values can look kind of neat. So now we can use a field to vary the amount of rounding at different spots along the ring. So open the palette and create a wave field. And then we're going to connect that up to the rounding field input on the Prism SDF. But in order to get a good range of values that we want, we could use the amplitude and offset there, but I find it to be kind of a little bit more intuitive to rescale the values with a separate operator. So select the wave field here and open the editor tools with Alt-Shift-R, and then choose Rescale Field Simple. And then we can connect that up to the rounding field input on the Prism SDF. And make sure to mouse over the input so that you know that you're getting the right one, since the order and naming of these might change in future versions of the toolkit. So on the rescale field, since we're dealing with a sine wave, by default it's going to produce values ranging from -1 to +1. So in the input range, let's change that to -1. And for the output range, let's keep the bottom at 0. And then for the upper bound of that, let's go up to something like 4. And that will give us some interesting variety in that shape there. So then on the wave field, we can try changing the phase, and that's going to shift that pattern across the ring. So later on, we're going to add some animation to this, but for now, we're just going to drop it back to 0. So it's a little bit subtle, but it's going to make things more interesting later on when we have more copies of that ring interacting with each other. Now, before we continue, let's apply some optimization by locking in a few of the parameters. In the recent optimization series, I got into a lot of detail about why this works and where to apply it, but for purposes of this video, I highly recommend But for purposes of this video, I'm just going to walk you through doing it in specific places. And you could skip this if you want, but I highly recommend doing it because I've encountered some crashes while making the tutorial. And this helps keep things simpler, easier on your GPU, and less likely to have crash. So the first part that we're going to be doing is on the wave field here. We're going to go to this wave type parameter, right-click the name, and then choose toggle read only. Then we're going to go over to the Prism SDF, and we're going to do the same thing on the Prism type. And if you use the custom number of sides, you can also do it on that if you want. Then we're also going to do it on this hollow toggle here. So what that does is kind of bake those settings into the shader, and that reduces the load on the GPU by simplifying the code. When we just have a couple of operators here, it doesn't really make that much of a difference, but once we start stacking things up throughout the rest of the scene, it's definitely going to have an impact. The next step is to have multiple instances of this ring with different rotations on them. So let's create an instance operator. And we're going to insert that between the Prism SDF and the renderer. On the instance operator, let's bump the instance count up to maybe 6, or you could do 8 if you want. Now, right now, we aren't really seeing anything, and that's because all the instances are exactly the same and they're in the same spot, so they just kind of sit on top of each other. So what we need to do is to make them rotate by different amounts. Now to do that, let's first create a rotate operator and insert that between the prism and the instance. To vary the amount of rotation for the different instances, we need to access information about which instance it's currently working on. So select the instance operator and open the editor tools menu with Alt-Shift-R. And then under reference variable, we're going to choose normalized index. So this gives us a value that goes from 0 for the first instance to 1 for the last instance, and then kind of interpolated between those for the ones in between. In order to take this number, single number produced by that variable reference, and produce vectors, which will have rotation along all three axes, we need to first convert it to a vector. And there are various ways to do that, but in this case, let's select the variable reference, open the editor tools with Alt-Shift-R, and then choose Rescale as Vector. And then we can connect that up to the rotate field input on the rotate operator. The rotation amounts are specified in degrees, so this tiny range of 0 to 1 isn't really going to show anything yet, so we need to bump those up. So for the output high range, let's try increasing that, and now you can see the instances start to spread out. So you can try adjusting that on the various axes here, and that will give you some variation. So pick whatever ranges you like. I'm going to go with kind of 0 to maybe 250 or so, 240 for the X, and then for Y, maybe like 0 to 300 or so, something like that. The goal is to kind of get them sort of scattered across the area so that we kind of spread them out more rather than having them just like clustered together in one sort of fan shape. You can also do some on the Z-axis if you want, but doesn't have as much of an impact, but yeah, use whatever rotation on there you feel like. Now that we have a bunch of instances with different rotations, they're kind of filling up the space too much, and it makes it a little bit hard to see what's going on there. So to adjust that, let's go back over to our Prism SDF, and then we're going to drop down the thickness and the height. I'm going to use values of 0.01 for both of them. They don't necessarily have to be the same. If you want to have like a thin flat ribbon, then you could use a higher height and a lower thickness, or the reverse, but general idea is to kind of get those down so they're fairly thin. So now if we go back over to the instance, we can change the combine mode here from simple union over to smooth union, and that's going to start blending out the different instances together. You can adjust the amount of blending or the distance over which it blends using this radius parameter. So set it however you like, but I'm going to go with something that kind of right around the default of 0.5, maybe a little higher, so that it's mostly solid with a few holes through it. So now if you go over to this rescale field where we're specifying the range of rotation and try shifting some of those values around, you're going to get some really interesting movement in there. Once we get to the animation stage later on, it's going to be helpful to have an easy way to add motion to all the rotation values with some nice variation across the instances. You could do that by animating the individual parts of the rotation ranges here, but it would be helpful to have that available as just like a single number that we can animate. So there are lots of ways we can do that, but we're going to try, in this case, using another sine wave. So let's select this variable reference here, and we're going to use a new shortcut that was added in 0.38. So select that, open the editor tools with Alt-Shift-R, and then under Apply Wave, choose Sine. And that's going to create a wave field with that connected to its first input. To convert this to a vector, we're going to do the same thing that we did before. So with that wave field selected, open the editor tools with Alt-Shift-R, and then choose Rescale as Vector. To use both of these, we want to combine those so that they produce a single field. So select both of those rescale fields, open the editor tools again, Alt-Shift-R, and then under Combine Fields, we're going to choose Add, and then connect the resulting Combine Fields operator to the rotate input. Now on the rescale field, let's change the input range for all the parts to -1 since we're dealing with a sine wave as the input. Then for the output range, you can pick whatever values you want, but make sure the values are large enough to have an impact since we're dealing with degrees. Now if we go over to our wave field and we shift the phase there, it adds some interesting motion, and then that's just a single parameter that we can animate that will give us a kind of continual variation of motion. And we'll animate that later on. Let's apply some optimization before we continue on to the next section. This is going to be similar to what we did earlier. So on the wave field, right-click the wave type, choose toggle read only. Then on the instance, do the same thing for the combine mode here, so toggle read only. Then on the combine fields, you're going to switch on this optimize setting. And then on the rotate, you're going to do the same thing, switch on the optimize setting. And with that, using that optimize setting on these two operators effectively bakes in all the other parameters. So if you change them, the shader is going to have to recompile and Touch Designer is going to stall. But if you aren't changing them, it makes things a lot faster. Next, we'll add a material instead of just using the default one that's built into the renderer. So we're going to create a modular mat, and we're going to insert that after the instance. Then with the modular mat selected, open the editor tools with Alt-Shift-R, and under Add Diffuse, choose Orin Nyar. Then we're going to select the modular mat again, open the editor tools, Alt-Shift-R, under Add Specular, choose GGX. You can also try experimenting with different shading methods in there if you want, but I tend to like this combination. Now let's add a light instead of using the default one that's built into the renderer. So select the renderer, open the editor tools with Alt-Shift-R, and then under Add Light, you're going to choose Point Light. Now you may notice that we're suddenly seeing everything in grayscale, and that's because the default light that's built into the renderer has a little bit of a tint to it, and our new point light doesn't. On the position for that one, let's move it a little bit to the side, so maybe like 2 for X, and then a little bit up, maybe 4 or so, and then back to maybe 6 or yeah, something around there. That gives us some interesting variety on the amount of light that's hitting different parts of the surface. Then let's go back to our shading elements. So on Diffuse Contrib, going to bump the roughness and albedo up to about 1 for both of those. And for the specular contrib, I'm actually just going to keep it the way it is with the roughness at 0.5 so that we get a little bit of a kind of metallic shine on it. But we could even drop it down a little bit, so maybe 0.4 or something around there. Next, let's optimize the material. So on the diffuse contrib, we're going to do similar to what we've done before. Right-click the method here, choose toggle read only. Then we do the same thing on the specular contrib. And doing this on these particular operators tends to have a pretty high impact on performance, so I usually do that once I've chosen which shading method I want to use. Next, we'll add color variation by assigning the surface color attribute to the different SDF instances. So open the palette again and create an assign color. And we're going to insert that between the SDF and that rotate. We're going to do something pretty similar to what we did for the rotation there, where we're using that normalized index variable. So I'm going to make a copy of that variable reference, so copy and paste, and then just move that over by the assigned color. You could also reuse that existing instance and connect it to both places, but it's not actually going to have that much of an impact on performance, and I think this kind of keeps the network a little bit cleaner looking. To make things a little bit easier to see while we're working on this, let's go over to our instance operator, and for the combine mode, we're going to go back to simple union. And in order to do that, since we locked it, we have to right click here, do toggle read only to unlock it, and then go over to simple union. And we can skip locking it again since we're going to be changing it back in a sec anyway. So now we can see we got all the different rings in there. To assign color to those rings, we want to take this normalized index, the value going from 0 to 1, and map it to color values. Again, we're going to use a wave to take this value going from 0 to 1 and put it into a kind of more interesting repeating sine wave that we can shift around more easily. So select that variable reference, open the editor tools with Alt-Shift-R, and then under Apply Wave, choose Sine. And we could just connect this directly to the assigned color, but it's going to just give us grayscale values, and most of them are going to be dark because that sine wave includes values that go down to -1, which is going to make things pretty much disappear. So instead, what we want to do is take this single number field and map that to a color range. So there are a lot of different ways to do that. One of the most common approaches is to use a color ramp field, and that will give you a gradient between two colors. But instead, let's apply a rainbow pattern. So create a spectral color field operator, and then we're going to connect the wave field to its wavelength input. Then we can connect the spectral color field to the assigned color. This operator takes in values representing a wavelength of light and produces different types of rainbow-based colors off of that. By default, it's expecting values that go in a 0 to 1 range, but you can also use nanometers if you want to be all sciencey, but I'm going to keep using 0 to 1. Now, since our wave field is producing values that go down to -1, we want to scale that so it goes to 0 to 1 range. So for the amplitude, let's drop that down to 0.5, and then the offset up to 0.5. So that gives us a 0 to 1 range. Now, if we try adjusting the phase on that wave, we get that pattern shifting across the instances. You can try out some of the different spectral color field options. So there's different spectrum types. So they have kind of, some of them are sort of subtle differences, some of them are a little bit more pronounced. So I'm going to go with Spectre. Now you may notice, if you're shifting this wave around, that there are instances in there that are often, pretty dark, if not invisible. And that's happening because the very edges of that spectral range kind of go out of visible range of colors, so they end up effectively being darker. Now you could adjust the amplitude on the wave here to kind of pull it in so it's doing a narrower range, but I actually kind of like having some that sort of appear and become darker and then brighter and so on, so I'm just going to leave it as it is. Then let's go back over to our instance operator, and we can go back to smooth union, and then right click that and do toggle read only to lock it in again. So now, since we have the different color assigned to each of the instances, when it blends between them, it creates these really interesting gradient patterns. Before we move on, let's just lock in the settings here for optimization. So on the wave field, right-click the wave type, choose toggle read only. Then on spectral color field, we can do the same thing for both of these parameters, so wavelength unit and the spectrum type. Next, to add some more variety to the shape, let's apply some twisting around an axis. We're going to do that by creating an axis rotate and insert that after the instance operator before the material. So it'll take a second while the shader recompiles since our scene's now getting a little bit bigger. But once we have that in place, let's create another wave field that will vary the amount of rotation. Then connect this up to the second endpoint on the axis rotate. For both of these, I'm going to change the axis to Y. And it ultimately won't end up mattering that much which axis they are on, but it helps for them to be on the same axis unless you want to get some kind of more unusual patterns, which maybe that's what you want to do. If so, try out lots of stuff, see what looks good. So then on the wave field here, since we're dealing with degrees, we want larger values. So I'm going to bump this up to something like 30 and then spread the wave out maybe to something like 6. So now we can shift that phase and we get that kind of interesting twisting motion there. So now let's apply some optimization here. So in the wave field, right-click the wave type, choose toggle read only. Then we're going to go over to the axis rotate and do the same thing for its axis parameter. And at least in the current version of the toolkit, doing that on the axis parameter on the wave field doesn't actually improve things, but I mean, you can do it if you want. It shouldn't hurt anything. It just may not provide much of a benefit. So next up, let's add some spin to the whole overall shape. We'll do that with another rotate operator. So create a rotate, and we're going to insert it after the axis rotate here that's doing our twisting. So when that takes a second to recompile, and this kind of stall will be a lot worse if you don't do that optimization as you're going through things. So now on the rotate here, we can, rotate the different axes, and that moves the whole shape overall. So later on, we'll add some animation to it, and we're actually going to hold off on optimizing this one until after we've done the animation. So that brings us to animation. We're going to do that animation by shifting the phase of a bunch of the different wave fields that are in the scene. And then we're also going to do it for that final spin there. So let's start with our SDF and the wave that's controlling the rounding of those rings. Select the wave field here and select just that one. Open the editor tools with Alt-Shift-R, and then under Animate with Speed, choose Phase. And I'm just going to move this back over here. So then on the speed generator, I'm going to drop the speed down, maybe around 0.1, 0.2, something like that, so it's less intense, but still gives you some interesting movement. Next, we're going to go over to where we're assigning the color, and we've got another wave field here, so we're going to do the same thing there. So select the wave field and just that one operator, open the editor tools with Alt-Shift-R. Open the editor tools with Alt-Shift-R. Open the editor tools with Alt-Shift-R, and then under Animate with Speed, choose Phase. And again, we want to drop the speed down there to something more reasonable. So maybe something even lower, like 0.05 or 0.6 or something like that. Next up, let's go over to our instance rotation. So it's over near our instance operator here. We've got this wave that's applying the rotation. And before I do that, I'm actually just going to adjust my range there because I get these big holes on the side that I don't particularly like. So just kind of shift it around until things look a little bit more solid. Okay, so then over on the wave, select just that one operator, open the editor tools with Alt-Shift-R, or animate with speed, choose phase. And then again, let's drop the speed down to something more reasonable, maybe even lower. And you can try doing that with either a combination of the slider and the first speed parameter there. I like to sometimes use the first one to kind of define like a reasonable base value, and then use the second one as like a slider that only goes up to whatever value you have set there, since it multiplies the two. But general idea there is just slow down the rotation so it's less intense. And next, let's go over to our twisting. So that's over by our axis rotate. We can do the same thing on this wave field, so select that and open the editor tools with Alt-Shift-R. Under animate speed, choose phase. And again, we want to drop the speed down to something a little bit more subtle. So next up, let's do our spin. So let's select that rotate operator, and then editor tools with Alt-Shift-R, and then under animate with speed, and on this one, we're going to choose rotate XYZ. So that's going to allow us to apply that rotation to all three axes, and we can use different speeds for each of them. Now, since this one is controlling the amount of rotation and not the phase of a wave, we need those values to be larger. So one way that I like to do that is just increasing the value multiplier, so to something like 30. Now you could also do that by adjusting the speed, but I find just logically it tends to make sense to use value multiplier to make larger values, since it's less of more thinking about it in terms of the scale of the value and less on the speed of the value, if that makes any sense. So now you can use the individual parts of the speed parameter here to change how much it rotates on the different axes, and then you can use the multiplier here to kind of scale that overall rate. And that's it for the animation. So you may notice in the rendering that there are some times where things get a little glitchy around edges. So you get some kind of these like stripes that'll show up along some of those hard edges. And to make this a little bit easier to see while we're working on it, I'm just going to go over to all these speed generators and switch those off using their play parameter. Interesting thing about the network editor, using this separate panel here, it won't let you change multiple at the same time, but that's why I'm popping up this one temporarily. So now that we have all of those paused, it's going to stay nice and still while we clean it up. If you are trying to find those on yours, I can recommend like letting it play until you see something and then pausing, and then you can stop those if you want. So the ideal solution to this, and the one that a lot of people kind of come to as their first option when they encounter things like this, is anti-aliasing. Now, before attempting that, save your file. This can be an area where stability can be an issue. Now, in the first video in the optimization series, I get into a lot of detail about why anti-aliasing is so expensive in terms of performance. But for now, for purposes of this video, just know that it is costly, very costly. Now, before you attempt to change it, make sure when you're doing this to type the values into the number field rather than dragging the slider with your mouse. Every time that value changes, the shader is going to recompile, and if you are dragging your mouse, it's going to do it many, many times, which is going to stall Touch Designer or possibly crash it. So select the text in there, type in a value like 2, wait for it to do its thing and recompile. And this may take a little bit, especially since we have a lot of stuff going on in our scene now. But whenever this finishes, we're gonna see that there is kind of an improvement. So we get a little bit of the like pixelation is gone, but there are still these kind of weird hard edges that don't look great. So it fixed it in there, but over here, we can still see some issues there. So you could try to bump the anti-aliasing up even higher, but this is already getting frame rate drops on my machine here to like down to 17 frames a second sometimes, and this is on a 4080 Super, so you're likely going to have performance problems. So if you increase that higher, then it's going to get much, much worse. And it isn't really fixing the issue anyway, so let's go back to a value of 1. And let's find some other ways that we can address that. So to really address the issue, we would either need to bump that, so high that it's barely going to be able to run. But even then, that probably wouldn't fully solve the issue, since aliasing itself is only kind of one of the problems here. So you'd still end up having to do some other stuff to fix it, so let's use this post-processing approach instead. Instead, we're going to come at this from kind of 2 angles. Now, the areas where we're having problems here are places where there's kind of a sharp change in the surface, so a hard edge. And that means that there's going to be a rapid change in the direction that the surface is facing over a short distance, and the renderer doesn't really handle that well. So what we want to do is kind of smooth out those surface normals. Fortunately, there is a way to do this that's built into the renderer. So if we go to our renderer, go to settings, and then go to normal smoothing, it's on the settings page there. I may move this around in future versions of the toolkit to kind of organize things a little better, but if you don't see it under a settings page, then just search through the other ones to find it. So switch on that toggle there. It's going to do its thing while it recompiles. And once that is done, we can adjust the smoothing. So what this does is it spreads out the range over which the renderer kind of looks at the surface of the SDF to determine what direction things are kind of sloped or facing. So the result is that it kind of smooths out hard changes in the surface normal. So you can get some kind of weird things going on if you push it too high. So I'm going to keep it fairly low. Maybe like 0.06 or something, 0.006, 0.5, maybe a little higher than that. 0.01 seems to work okay. Okay. So the result is that those surface normals get rendered out a bit. Now, it isn't actually changing the shape of the surface, it's just changing the surface normals, so we're still going to get some kind of weird stuff going on in there, but it did help somewhat. So next, we want to deal with kind of the rest of this issue. And to do that, let's try an approach that's using post-processing on the rendered output. So I'm just going to make a copy of the null top here so that we can make it easier to kind of insert things later on. Now just moving stuff over here, and then let's go over here. Okay. So gonna insert another null here just so that things fit well on the screen. Now, there are a bunch of different ways that we could try to approach this. There is the anti-alias top that you could try inserting there. It's often a good option. It's much cheaper than doing it in the renderer itself, but at least when I've been experimenting with this particular scene, it doesn't really tend to solve the issue. So let's try a different approach. So instead, we can make our own sort of rough approximation of what that does. We're going to do that by looking at the surface normals from the renderer and then trying to identify where the edges are and then apply a little bit of blurring just to those spots. So first we need to get access to those surface normals. So go over to your renderer, select that, open the editor tools with Alt-Shift-R, and then under Select Output Buffer, choose Normal. It's going to do its thing while it recompiles for a sec. Since before this, it wasn't preparing the normals for output, and now it's going to. So now we can look over here and then add a null top to the output there so we can see the result. So just going to center things there. All right, so this is giving us the direction of the surface normal for every pixel on the screen in the rendered image. The different parts of the vector there are doing the like X, Y, and Z parts of the vector indicating the direction. So what we want to do is find places where those change rapidly. There are different ways that we can try to identify those. What I've found works fairly well is to convert it to HSV and then look at the hue. So let's create an RGB to HSV top and then just stick that on the end. And then with that, we can, I'm just gonna add another null here to make it easier to see what's going on. Okay, so that gives us in the red channel the hue. So next we can use an edge top and switch that over to use the red channel, first channel, which in this case is the hue. So that's doing a decent job of picking up spots where there are hard edges. So, you know, it's not showing up too much in areas where things are more smooth, and it's giving us those places where it's a little bit harder and the sharper edges. So next we can take this and use it to selectively blur the rendered image. So let's go over and create a Luma blur. And then we can connect the main render output to the first input and then our edge top to the second input, and then wire that in and look at the result. So zooming in here, we get a little bit of an improvement there. You can try kind of toggling this on and off to see the difference. It's kind of subtle, it may not even really come through that well in the screen recording, but it's there. But it's not quite addressing the issue that well. And part of that, I think, is because the edges that it's identifying are a little bit too tight onto just exactly the spot where it's you know, detecting the most of a shift in the direction. So what we want is to kind of give it a little bit of a buffer around the areas that are kind of next to that. Now you could try doing that with sample step in the edge top, but that can introduce some kind of pixelation and glitches there that may not serve us well here. So instead, let's create another edge top and then just insert that there. And then on this one, we can turn in comp over input. So now that is applying an edge to the edge, so it's kind of giving a little bit additional area to the parts that it thinks of as edges. Then over on the Luma blur, we can try bumping up the white filter width. This is the amount that it's blurring on the edges. Bump that up a little bit, maybe 12, 13, something like that. So now that cleans up most of the issues there, and I think we're in a good spot. Next, let's add some post-processing on the result of this. We're going to do that with the bloom top. The bloom top was recently added in Touch Designer, and it's really great. So let's create one of those and stick it in there after that Luma blur. And then just going to switch over to that output. Home things in there. There we go. Okay. So the bloom operator has a lot of different options. The general idea behind it is that it adds kind of a glow shine to bright areas of the image. Now, you can try different settings there, but I think I've found some good results dropping the pre-black levels. This is kind of like the minimum cutoff for areas that it applies bloom to, and maybe increasing the intensity a bit. And you can kind of dial this in however you like. Try adjusting the range there. So that's lots of different options here. This is probably a whole other video in and of itself, but general idea is to give it kind of a little bit of a glow there. So once that's all done, I'm just going to switch back on the animation. So do that with selecting all of these speed generators, popping up this extra parameter to deal with that bug in the network editor, hit and play on all those, and then hiding that over again. So now that things are moving, we get a better sense of where that glow is coming through. One thing that I noticed while going through this that you may be seeing there is there's kind of an occasional flicker or dropout. It looks like that's a bug in the bloom top itself. So if you're seeing that and that's causing problems, you can try switching that off or adjusting the parameters there to see if you can avoid it. So you can then kind of go in and refine this to whatever you want. So that's it for this scene. So to recap, we are starting with a SDF ring that we're making out of a prism SDF with the hollow setting on, and then it's kind of short and wide to make a ring. We're applying variable amounts of rounding to it to give some variation to the shape. Then we are taking the resulting SDF, we're creating multiple instances of it, we're combining those using smooth union to create this sort of blended globby shape. We're then varying the rotation using a field here that's based off of the normalized instance index, and then applying rotation there. Then we're doing something similar for the color, where we've got another field here using a sine wave, applying this spectrum-based rainbow color to the different instances. Then we are taking the result and applying some twisting around one of the axes, and then we're also applying some spin to the whole thing overall to give it some general motion. Then we've got a modular material with diffuse and specular shading, a renderer, and then to clean up some of the glitchy edges, we switched on the normal smoothing on the renderer, and then we're using the normal map to sort of clean up the result by identifying the hard edge areas and blurring those a little bit. From here, there's lots of different stuff that you could do with the scene. You could try swapping out different types of SDFs as the basis for it, or you could use different combine modes on the instances, or different kinds of distortion, twisting, rotation, whatever you want. So lots of different ways that you could expand on this. So look forward to seeing what you all do with this. And if you post on social media, use the RayTK hashtag. And at least on Instagram, to make sure that I see it, if you want to show stuff off, just tag me directly, and yeah, that'll I'll broadcast your stuff to the community so that folks can see what you've been up to. So that's it. Thanks for watching. If you want to support RayTK development, subscribe to my Patreon. You'll get early access to tutorials, scene file downloads, and a bunch of other stuff. And even if you don't want to pay, you can subscribe for free as a way to get announcements about the toolkit. Anyways, thanks for watching, and make sure to like and subscribe.